Hey everyone, we're here today to talk about a topic that came up when my AP students did a practice exam recently. And it was really interesting to me that this one small topic, a lot of my students had not caught the first time through. So I just want to do a quick explanation of it. Maybe your students are also in the same position. Feel free to use this video with them. And this topic is the parallel axis theorem. So I think a lot of you uh, when you're talking about rotational motion, right, we're talking about moments of inertia. And so if you remember from this, it's kind of the analogy to mass, right? It's how easy something is to rotate. And so if we have like disks versus hoops versus spheres versus shells, they all have different moments of inertia. And we can calculate those using an integral. Although usually in this class we don't end up doing that. We usually have very standard shapes that we use. Now, the parallel axis theorem is a nice little trick, and it lets us take a situation where maybe we have a shape, let's say a disk, whose moment of inertia we do know around some axis. So in this case, we know the moment of inertia for this disk through the center of mass. Okay, so through the middle of the disk. So we are going to call that ICM, and we know that that's 1/2 mr squared, where r is the radius of the disk, and mass is the mass of the disk. But what about I have the same disk, and I want to rotate it, but instead I want to rotate it around a different axis? What if I wanted to rotate it along its edge? What would my moment of inertia for that be? And so this is where the parallel axis theorem comes into play. And so the parallel axis theorem basically tells us that as long as we know the moment of inertia for the object through its center of mass, we can actually really easily calculate it through any other place. And the way we do that is take the center of mass, moment of inertia, and add mass times d squared. So this d is the distance from our previous axis to our new axis. So here, it actually conveniently is the radius, right? So here we would have 1/2 mr squared, which is just the initial moment of inertia, plus another mr squared for shifting the axis. We get 3/2 mr squared. So this is super helpful if you look at a problem that has a kind of shift of viewpoint, a rotation around something that you maybe didn't remember. Super, super helpful way of doing it without having to do any of like the additional calculus. Highly recommend remembering your parallel axis theorem. It will make your life a lot easier. Have a great day. Bye.